Hi, everybody. My name is Gigi Drent. I am from Kauai Community College. Today, we are going to learn about solving linear equations. So let us get started. Okay, so solving linear equations. You have learned from before order of operations, right? So order of operations is when you have an expression. You will use order of operations to evaluate. And what that order is you've heard this before. Please excuse my dear Aunt Sally, right? Parentheses, exponent, multiply or divide from left to right, and then add or subtract from left to right. We will use order of operation to not solve, but to evaluate. I just make that mistake, right? To deal with problems like this. Evaluate this expression when x is 5. Okay, so when x is 5, what we will do is substituting 5 in for x so that we have this with the 5 where the x was. Then order of operations will apply here. Please excuse my dear Aunt Sally. Parentheses will go into to the parentheses, and 5 minus 3 is 2. And then exponent is next. 2 to the third power is going to give you 8. Then here at this step, you have multiply, divide, add, or subtract. So multiplication or division from left to right. So going from left to right, I'll multiply 2 times 8, give me 16, and then divided by 4, give me 4. The last order is to add or subtract from left to right. So 9 minus 4 is 5, and 5 plus 7 is 12, right? So that's what it means to use order of operations to evaluate an expression. Okay, now what we're learning in this lesson is to solve an equation. So how is that different than order of operations? To solve an equation is to actually go in reverse. So you are undoing the order of operations to get the variable that you want. Okay, so for my Math 75x100, go ahead and find your L1 handout number 13. Pause the video if you need to. If you're not in my class, hey, get out a piece of paper and take notes. The question asks for you to solve for C in this equation here. Okay, so if we look at it and think about where C is right there. What is being done to C? It's being multiplied by 9, divided by 5, and then added 32 to it. So to solve an equation is to go backwards. So whatever the last thing is that I said, which was plus 32, I'm going to go ahead and undo that first. Okay, so minus 32 to both sides, I will have f minus 32 is equal to 9 over 5 times c, right? So 9 over 5 times c. That means c is being multiplied to 9 and divided by 5. And the last thing I just said is the first thing I'm going to undo. So to undo dividing by 5, I'm going to go ahead and multiply by 5, but to both sides of the equation, right? So remember, an equation is like a balance. So whatever you do to one side, you do to the other. And you will get 5 times f minus 32 in parentheses is equal to 9 multiplied to c, right? That's what it means. 9c means 9 multiplying to c. And I said multiplying, so the inverse of multiplication is division. So I'm going to go ahead and divide both sides by 9, which I will have c is equal to 5 over 9 times f minus 32 in parentheses. And that's how you isolate a variable. And you would do that a lot in your science classes, right? Now, when encounter a problem where you have to solve an equation to find a value, you would see something like this. That would be in your L1 handout if you are in my Math 75X. Otherwise, write this down and take notes. Okay, whenever you see pause and wonder, go ahead and pause the screen and wonder what you should be doing. So once you have done that, let's take a look. Now, you have x's on both sides of the equation. So your choices would be, well, I can go ahead and minus x to both sides, or I can go ahead and add 7x to both sides. What would be a better choice? Either way is fine, but we are going to go with, I'm going to go with plus 7x to both sides, because then I will have positive 8x on the right-hand side instead of having negative 8x on the left-hand side if I was to subtract x to both sides. So I kind of just like having a positive value next, positive coefficient next to the x, because I tend to lose those negative signs and then I make major mistakes, right? So now that becomes a very simple linear equation. 8 times x plus minus 14 equals 6. So add 6 to both sides. 8x. Now, why did I just add 6 to both sides? I have no idea. You do this all day and you just get confused. You want to add 14x to both sides, not 6. Okay, so add 14 to undo minus 14. On the left-hand side, I have 20, and then here is multiplication, so you divide by 8 to get x by itself. So you have x is equal 20 over 8, which reduced to be 5 over 2 because 4 goes into both of them. Okay, now before you actually circle that answer and say, oh, hey, x is 5 over 2, you better check your answer. Okay, and what does it mean to check your answer? Is to substitute x into the equation, use order of operation to evaluate the left-hand side and the right-hand side to make sure that they are the same. Okay, so 6 minus 7 times 5 over 2, does it equal to my right-hand side, which is 5 over 2 minus 14? Okay, here we go. Multiply first, right, on the left-hand side. So I have negative 35 over 2. 6 is the same as 12 over 2. What I really have on the left-hand side, common denominator, keep the same. 12 minus 35 is negative 23. So whatever I have there on the right-hand side, it's better be the same as 23 over 2. Otherwise, the equation is not true, and 5 over 2 is really not your solution. So make sure that they're the same. So 5 over 2 minus 14 is the same as 28 over 2. That's a funny looking 8 there. Common denominator is 2, so we'll keep that. 5 minus 28, of course, is negative 23. So yes, they are the same. And since they are the same, x equals 5 over 2 is a good answer. Okay, let's take a look at something that's just a little bit more involved. So pause and wonder what you should do first. Once you have done that, you will see that this equation involves distributive property. So we're going to go ahead and distribute the 3 into both of these, which will give you 6x minus 15, because 3 times 2x is 6x, 3 times negative 5 is negative 15, minus 7 is equal to, distribute the 4 into each one, 4x minus 36. Now it almost looked like equation number 1 that we had just dealt with earlier. So we'll go ahead on the left-hand side right there, combine like terms here, right? So within one side of the equation, all you could do is to simplify. So you just combine like terms there. So what you really have here is 6x minus 22 is equal to 4x minus 36. We have learned from the last problem, so we will go ahead and minus 4x to both sides. That will give me 2x minus 22 is equal to negative 36. To undo subtraction, we will add. So add 22 to both sides, and 2x will equal to negative 36 minus 22 is 14 divided by 2. X is negative 7. Okay, so to confirm that x is actually negative 7, we will go ahead and check our answer by substituting 7 back into the equation. So I have 3 times 2 times negative 7 minus 5 minus 7, that's the left-hand side. Does it equal to 4 times negative 7 minus 9? Okay, the right-hand side look a little bit simpler, so I'm going to do that first. 4 times negative 7 minus 9 is negative 16. Positive times a negative is a negative. 4 times 16 is 64. Now, how do you think about that? 4 times 10 is 40. 4 times 6 is 24. 40 plus 24 is 64. That's one way of thinking about it, okay? So here on the left-hand side, we have 3 multiplied by, parentheses first, order of operation. And within here, we will multiply before we subtract. So negative 14 minus 5 minus 7. Negative minus 5 is negative 19 multiplied by 3. 3 multiplied by 19. Positive times a negative is a negative. I would say 3 times 20 is, if I have 20 copies of 3, then it's 60, but I only have 19 copies of 3, so that must be 57. And minus 7, that would give me negative 64. So negative 64 is equal to the right-hand side, which is negative 64. Then your answer is a good answer, and we can go ahead and circle this to check. Okay. Could it get any more complicated than this? Yeah, maybe. You don't encounter this very often in Math 100, but just in case, we'll take a look and make sure we have a strategy. Okay, so look at L1, handout number 5. Pause and wonder. Okay, now once you have already paused and wonder, you will see that there are denominators here, these weird fractions here, right? So this is an equation, and what we know from solving an equation is whatever we do to one side, we do the same to the other side, and that will keep it balanced. So I would say I want to get rid of all denominators at the same time. So I'm going to go ahead and look for the least common denominator between 4, 5, and 2, and that would be 20. Okay, so the trick here is I am going to wait, not do that, but I'm going to go ahead and multiply both sides by 20. And multiply both sides of the equation by 20. Okay, how does that help? Well, as you can see, this 4 goes into 20 5 times. So I have 5 times x plus 2 that is left on my first term. My second term, 5 goes into 20 4 times, and I have 4 times x minus 1 is equal to, on the right hand side, you can see that 2 goes into 20 10 times, so 10 multiplied by x plus 3. And we have just turned that into equation number 3, right? The last one we just saw. So distributive property, get variables to one side, solve for x, and then check your answer. Okay, you can go ahead and finish that on your own, but that's how you would deal with things with a denominator. Multiply both sides by the least common denominator. That will zap all the fractions. Okay, now what I want you to think about after you finish this one is something like this. Say 0.12x minus 0.7 is equal to 3.6x plus 2.15. Okay, so we have just learned then that when you have fractions, you multiply both sides by the least common denominator to clear the fractions. Well, how do you clear decimals? How do you clear decimal? What do you think is a good trick here? Okay, pause and think about it. Gonna multiply both sides by the same number. What number is good in this case? 2 decimal place, 1 decimal place, 1 decimal place, 2 decimal places. And what does it mean to have 2 decimal places? It's over 100, right? So 0.12 is 12 over 100. So what number am I going to multiply to both sides? 100. And guess what will happen when we do that? It just turned into a very nice looking equation. So that's how you clear decimal. Same as how you would clear fractions. Multiply both sides by the least common denominator. Okay, so that's it, folks. That's it for solving linear equations. See you next time.